Lesson 5-4, Day 2, Solving Compound Inequalities that are separated by the word or. What are the three types of graphs that may represent a compound or inequality? That's our essential question today. When the word or is separating our inequalities, what is formed is called a union. A union is different from an intersection. In an intersection, all you're doing is looking for where they overlap. So the intersection was just this red piece that I'm shading. So it was where what they have in common, like members that are common to two different sets, those are part of an intersection. A union though is when you unite together two groups, and if you unite together two groups, you are counting everyone. So a union is not just the piece in the intersection. A union is when everyone counts. So you don't have to be a part of both groups. You could be a part of one group or the other group or both, and you count just the same. So think of a union as uniting together where everyone counts equally. So we have two real world examples for you. To ride without a car seat, this used to be the rule maybe about, 10 years ago or a little bit longer than that. To ride without a car seat, a child must be at least 4 years old or weigh at least 40 pounds. So what is the significance of the word or? Shade the union of these two sets. Well, the union, like I explained on the last slide, in the union, everything counts. You just unite them together. So the union represents everything being shaded. So what is the significance of the word or? The word or means that you could be one or the other, or you could be both. This piece where they're both. And it doesn't matter. So any of these requirements would be okay to be able to ride without a car seat. So let's say that you were 4 years old, but you didn't weigh 40 pounds. That was okay when the word was or, because you just had to be one or the other. So anyone that was 4 or older could ride without a car seat. Anyone that weighed 40 or more pounds could ride without a car seat. And if you happen to be both of those things, then great. You could ride without a car seat. So the requirement was just one or the other. You didn't have to be both of them. This next example says to get a discount at Perkins, a person must be an armed services veteran or at least 60 years of age. So we've got these people in the middle that are both. They're veterans and they're 60 or over. They get a discount at Perkins. But we've got this other group over here. These are veterans. They're just younger than 60. They still get the discount. Then we've got this group over here. These are people that are at least 60, but they aren't veterans. They still get the discount at Perkins. So it's one or the other or both. They all get the discount. Now let's talk about the three different types. The first type is the most common, and this is called two rays. Two rays. I'm going to label my number lines from 2 through 6. 2 through 6. And we're going to talk about what happens here. Greater than 6 would be this ray. Less than 2 would be this ray. So if you just have to be on one ray or the other, or both, well, nobody's on both of those rays. They don't overlap. But you just have to be on one or the other to be in the solution set. So I need them both. So my solution set is formed by simply putting together both of those rays. So if you're less than 2 or greater than 6, there's the graph that would represent our situation. Type number 2. Now we've got the word or. So I'm going to set up my number lines again. We've got the word or again. We go from -1 to 3. The first graph is going to be an open circle, greater than -1. The second one, a closed circle, greater than or equal to 3. Now, if I combine together these two rays, I combine together because you can be on one ray or the other one or both. They do overlap over here, but these points over here still count because with the word or, you just have to be on one or the other. So if I put these two rays together, my solution is going to start at the -1 and it's going to continue on to the right. So that ray, x is greater than -1, is actually our solution. It overlaps the greater than or equal to 3, and it includes all of these points. So since this entire ray is already included up here, we don't even need to write this inequality anymore. So our solution is just the ray starting at the -1. So x is greater than -1. Type 3, all real numbers, all real numbers. How does this happen? Our number line from 1 to 5. My first ray, greater than 1, goes to the right, open circle. Second one, less than or equal to 5, goes to the left with a closed circle. Now if I combine these together, like I unite them. So picture moving those rays like this together. What happens is we have covered the entire number line. Everything is covered. That open circle got covered by the other ray. So we've covered the entire number line. So this solution is going to be all real numbers. If I wanted to graph it on the number line, I'd have to graph the whole thing. Because every single number is included if we're looking for something greater than 1 or less than or equal to 5. So we've got our 3 types. Now we need to solve and graph and figure out what kind of solution we get. So we have 2 more examples where we're solving. So this one, I've got -2. And the second one, I get +3. So my number lines need to go from -2 to +3. Okay, my first one, less than or equal to -2. So it's going to the left. Second one, greater than or equal to 3. Going to the right. So if I unite these together, because it's a union, unite these together, they're not touching each other. So it's just going to be the 2 rays in opposite directions that are the solution. So combine them together in the same number line, and they're still separate, they're still 2 rays. That's your solution. And that's the most common type of OR number line graph. Most of them will end up being 2 rays in opposite directions. The next one. I solve and get x is less than or equal to 1. And I solve and get x is greater than or equal to 4. So my number lines need to go from 1 to 4. Less than or equal to 1 would go to the left. Greater than or equal to 4 goes to the right. So again, we have 2 rays and we just unite them together for our solution. You should be able to write your summary now. The 3 types of graphs that may represent a compound or inequality are, so explain the 3 types, and here are your homework problems.